Hello, this is the example from page 1116, where we are going to use the two surfaces to create the intersection curve. The first will be a revolved surface, the second one will be the sweep surface made around the spiral. And then we are going to create an intersection curve and create the solid sweep around the intersection curve, which then we are going to array and to get our beautiful candelabra. So we will start by opening this file, and the file name is, it is in your directory, the file name that we are going to, the file that is here is called the candle holder sketch. And we are going to save this as a candle holder sketch in our directory that we use. First thing will be to create a revolved surface of this curve around the axis. So we will go Insert, Surface, Revolve Surface. Axis of revolution is our central axis, and by default it will pick up entire sketch. And for a 360 degrees, and we click on a green button for OK. Here is our first surface that we will use. Now, the next thing that we are going to do, we are going to create a helix of the 10 inches in a diameter, and the helix will have a pitch of 21 inch with a 1 revolution and starting 0 degree. So, first thing what we need to do to start that helix is to create a circle on this plane, and that happened to be a top plane. So I will click on a top plane, and I will start a new sketch, and all what I will do is to make a circle with center of the circle coincidental with the origin, and diameter of the circle is 10. This circle will define, with a pitch, will define my helix. So I'm now going to insert helix, which is a curve, and that's under the menu Insert, Curve, and then Helix Spiral. And what it asks us is the pitch of the helix, and the pitch of the helix is going to be the pitch of the, it is actually a pitch, let's see, so essentially this one will be the 21 constant pitch, and the pitch is going to be at 21 inches, and we are going to have revolution 1 and start degree, and we are going to make it to be a counterclockwise. So here is our helical curve. Now what we want to do is to create a curve which is going to make, we are going to make a line and to create a cutting surface which follows this helix, and that will be the sweep. That will be the sweep of the line as a profile over the just generated helix. And for this one, all what we have to do is going to choose the top plane again. We are going to sketch on a top plane. Let's look straight down to it. I'm going to make it to be a transparent. And I'm going to make a line from the origin. And I'm going to make this to the other lines. So I'm going to make a line from the origin to the line of the helix. I'm going to stretch that line a little bit, and I'm going to click on the end point of the line and on the helix curve, and the only option that I can have is pierce. And that's absolutely must, otherwise we will not be able to do the sweep. So if we don't create this pierce relationship between the profile and the path, it will not work. Okay, so here is our sketch of the profile. We close our, and now I'm going to create my sweep. And that will be again the surfer sweep. So I'm going to go insert, surfers, sweep. And I do have a profile, is my sketch, my sketch profile is a sketch tree. And my path is going to be this guy. And if I click under the options, I'm going to have full of path and far path, profile type will be a non or minimum twist, and start and then tangency are known, and I'm going to click OK. And I'm going to return back to my shaded view. So you see what I have created? I have this now helical surface cutting through my revolved surface. So I have my sweep cutting through the revolved surface, the sweep surface cutting through the revolved surface. And what is interesting here is that that cut is a unique curve. So I now want to extract that curve and to use that curve to create my to use that intersection curve to create my solid body sweep, which will form the base of my chandelier. Before that, I will need to insert some axis, and that will be the axis at the vertical axis at the intersection of the two planes. And I'm going to insert this as a reference geometry, axis, two planes, and that particular vertical axis I'm going to create by intersection of the front plane and the right plane. Click OK. So created. Now I'm going to I'm going to use this axis in future for creating the array of my chandelier features. Now, what I'm going to do, I'm going to click on the insert curve, and I'm going to choose the intersection curve. Let's see, where is my intersection screw? Actually, it's under the tools, it's under the sketch, because that will create a 3D sketch. Tools. Sketch tools. Sketch tools, and there is an intersection curve. I will click on the intersection curve, and it asks us to select the entities. I will choose the face. And I'm going actually to choose from the tree, surface sweep, and I'm going and surface revolve. So that way I don't need to choose individual faces. Click OK, click OK, and as you can see, it has created a 3D sketch with a beautiful intersection curve. Very powerful technique actually. So now we have my intersection curve. Now I can hide the two surface bodies, because all what I need is an intersection curve. So I will open surface body directory, right click on it and hide, right click on my other curve, hide, and look what I have. And I'm also going to hide my helix, because I don't need a helix. I'm going to make the axis visible. So here is my intersection curve. Now what I want to do, I will create a solid sweep. So I will go to the sweep boss base, and that will be a circular profile of the 0.260 diameter, 0.260 diameter. And all what it asks us in this case is to choose the curve. And I can choose it also from menu and click OK. And you see how now, from the help of the two constructive surfaces, I have created this fully defined, fully parametrically defined twisted profile, which will be practically impossible to define any other way. Now, what we are going to do to complete our chandelier, we are going first to create a circular pattern, and then we can play with the top and bottom to create it into the real physical object. So, now we will use the axis that we have previously created to make a circular pattern. I will use the axis 1. I'm going to use the 12 times with the equal spacing over 360 degrees. And here are the 12 times, and actually that will be a bodice pattern. Well, let's see. Let's see actually if we can go without bodice, if we can try with the features first. I'm not sure if the features will work because they will create a separate bodice. Not, then we will go to the bodice. Well, features actually worked and it merged them together because they are tangentially touching. Look at this. So the features work. That save us a lot of time of merging the bodies after. So here is the structure of our chandelier. Now, what we want to do, we can make the base and the candle holder, and those are just the revolved objects. So if I go to the front plane and place a sketch on the front plane, I will sketch the sketch, which is on a page 1120. I will make it from here to the outer edge. Then I will make it vertical. And I will make it sideways. And let's put the dimensions there. So the distance from here to here is a 1. The horizontal distance is actually 6.5 by 2. Or let's see, actually 6.5 is actually correct. My mistake. Okay. The distance of this line here is a 1. The distance between these 2 points is a 1.5. And the vertical distance that's the 1. This one here is 3. And the distance between this point and this point is 2. 1.5132. That's it. So this sketch is fully defined. Now what we have to do, we have to do the revolve feature, revolve boss, and this is the solid object revolution in a 360 with the axis of vertical line. Okay, because that feature will result in a zero thickness geometry, and that's the problem with the error in a book. This actually line should be a little bit inbound. Let's edit back our sketch. If I delete this coincidental and this here coincidental. Now we can actually move this to be actually the correct solution for this will be that this point and this point here have some small distance of maybe 0.5. Now this will work. So if I have this to be a 0.5 and this one to be a vertical, now this is back to a fully defined, and now it is revolvable. And here it is. And we have to leave the, we have to make a fillet, and I will make fillet of 0.5 on the outside edge on the chandelier. Okay, so here is my chandelier. Now I'm going to make the top one in the same way, just going to be the revolved object with a holder for the candle. Save as I progress. So the top object, I'm again going to place a sketch on the front plane. Let's look straight into it. And we are going to make the vertical line to be coincidental with the I'm going to make this end point, my origin to be vertically aligned. And I'm going to make some distance. 20. It is 20.250 from the origin. And the other one is a 22.750 from the origin, the top. Now we are going to stretch this out to 1. To kind of make the sketch of this candelabra. And we are going to start placing dimensions. 21.125. Now, this distance is a this is a 0.125. Now, the rest is to make an angular dimension between the vertical line and here of the 10 degree. And then we are going to make this distance from here to here to be 0.875. And then this one is a 1 inch. And these two are parallel. And this distance here is 0.125. No, actually it is not defined. Let's define it as it is here defined. This vertical distance from the origin is 22.625. And then the midpoint distance is a 22.5, and that's correct, 22.453, so that's the correct. And there is one more dimension missing, and that dimension which is missing is the 1.625 plus 125, this vertical. 1.625 plus 0.125. And there it is, fully defined. Now, place also here a center line, and I'm going to revolve both. And now I'm going to add some fillets here. The radius 0.3 of fillet first, 0.125. That fillet will be here. Then there is a fillet of 0.375. And that fillet is on the other end. And then we have a face fillet, for which we are going to choose the top face, mid face, and bottom face. And here is our chandelier, fully defined and completed as a beautiful model, which is fully parametrically defined. We can change its shape by changing the parameters of the helix and the parameters of the profile of the revolved object. So we've seen how can we actually use the surfaces to create the derived intersection geometries, and then we use that intersection geometries to drive creation of the solid object. And this concludes this demonstration.